Okay, so we're going to go through your rules and procedures for electron configurations and orbital diagrams. Remembering that electron configurations is just simply a list of the energy levels, the sublevels, and the orbitals where the electrons can be found. And the orbital diagram is the visual depiction of those levels, sublevels, and orbitals. And so we need to go over the rules of the road. What rules govern where the electrons can be? Because they don't just fill those levels and sublevels willy-nilly. There is a rule that governs how those electrons are put in. Actually, there's 3 of them. So we're going to start first with Aufbau's principle. Aufbau's principle tells us that the electrons are added one at a time to the lowest energy orbital available. So electrons are added one at a time to the lowest energy level available. Meaning we are going to fill the 1s energy level before we fill the 4s, right? So because 1 is a lower energy level than 4, it's important we fill it first. There is a nice visual diagram that we can draw that helps us do this. It's called the Aufbau tree. So I'm going to go through drawing it, and we'll talk about how we fill each level in sequential order. Now, you'll see it if you look, like if you did a Google search for this, you can see it one of 2 ways, the way that I'm going to draw it, or literally upside down from what I'm going to draw. The arrows go the same way. You're filling it in the same way. It's just whether the particular author of that diagram went top down or bottom up. Okay, so I'm going to start top down by writing all of our S energy levels first. So 1s, 2s, 3s, 4s, 5s, 6s, 7s. So in our energy levels, remember that S is the least energetic sublevel. Okay? Then we're going to fill our next least energetic sublevel, which is P. There is no 1P. We start at 2P, 3P, 4P, 5P, 6P. Then we have D. There is no 2D, so we start with 3D, 4D, 5D, 6D. And then finally we have F. There's no 3F. We have a 4F. We have a 5F. Okay. In terms of filling these, if you take your paper, kind of turn it on the diagonal, and you draw in some lines, it'll tell you exactly how to fill. So we fill the 1s first, then we fill the 2s. Once we've filled both the 1s and the 2s, we fill the 2p followed by the 3s. Notice if you follow the line, you're going to go to 2p before you get to 3s. So 2p fills first, then 3s. Then 3p and 4s, and 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, 5f, 6d. 6d gets filled last. So if you just go on each arrow, one at a time, work your way down, it's almost impossible to get them out of order. Okay, and that's the order in which they fill. Now, the order in which the electrons are removed is slightly different. We will cover that when we start talking about ions, but right now we're talking about filling. All right, so Aufbau's principle. You fill the lowest energy first before you move on. Okay, pretty straightforward. The second principle we're going to look at is Pauli's exclusion principle. So we know that in these energy levels and sublevels, the electrons are found in orbitals, and each orbital can hold 2 electrons. So that's the first part of Pauli's exclusion principle. Each orbital can hold 2 electrons. Okay? But the caveat to that is they can hold 2, so 1 or 2, but no more than 2, but they have to have opposite spin. So with opposite spin. How do we denote spin when we're drawing something on a piece of paper? So when we draw in our electrons, Okay, we draw our dashed line to show the orbitals. So we could have 1 electron or we can have 2 electrons. And notice for the one where I drew 2 electrons, my arrows are 1 up, 1 down. That's how I show spin. So this would be clockwise and counterclockwise. So they have to be opposite. What I cannot do is have this. Up, up, that's wrong. Okay, down, down is likewise wrong. So if you're going to have 2 orbitals or 2 electrons in a single orbital, they have to be opposite spin. All right. And then the last rule of the road is Hunds Rule. So Hunds Rule tells us that the electrons will occupy equal energy level orbitals so that there's a maximum number of unpaired electrons. So the electrons occupy the orbitals of equal energy so that a maximum number of unpaired electrons results. All right, another way to say that is when we fill them in, we do the up, up, up before the down, down, down. So if I were to draw that out, that would be me going, so say we've got a p orbital, right? P has 3 orbital blocks. I would go up, 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 down, right? Not up, down, right? This is wrong. Got to do it this way. The up, up, up before the down, down, down. All right. So we're going to go through, we're going to do 3 examples. If you can count, you can do electron configuration, right? It's not hard. It's just keeping track of where you're at and how many electrons that you have. So we're going to do kind of a simple one first, and then we'll do 2 that have a few more electrons, and then we'll move on to the next thing. So the first one that we're going to look at is chlorine. Okay, so on my periodic table, I'm going to find chlorine. I see that chlorine has a Z number of 17. Well, this is a chlorine atom, so that means protons equal electrons. 17 protons means 17 electrons. All right, so I'm just going to start following Aufbau's principle, filling in my electrons to my energy levels, my sublevels, and my orbitals until I run out of them. Okay, so let's see if I can squeeze it. I'm going to zoom out just a little bit so I can get that Aufbau tree in where I'm going to be writing, and we'll go through and fill this out. The only piece that we need to make sure we remember is how many electrons can fit in each sublevel. So remember that S can hold a maximum of 2, P can hold a maximum of 6, D can hold a maximum of 10, and F can hold a maximum of 14. They can hold less than those, but that is the max. All right, so we have 17 to deal with. So I'm going to start at 1s. So in my 1s, I can have a maximum of 2. I have 17, so way more than 2. I'm going to put 2 in it, go on to the next one. And I have 2s. 2s can also hold a maximum of 2. I've used 2 of my 17. I have 15 remaining, so I can put a full 2 in here. So now I've used 4 of my 17. I got quite a few more to go. So then I'm going to go to 2p. Now 2p can hold 6. I've got more than 6 left, so I can put all 6 in there. So 2 plus 2 is 4 plus 6 is 10. I have 17 total. I've used 10. I have 7 left. So I'm going to slide down from 2p to 3s, 2. Now I've got 5 left, 3p. Now 3p can hold 6, but I don't have 6. I only have 5. All 5 are going to go in 3p. Double check my math. 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 5 is 17. I have taken care of all 17 of my electrons. So this is my electron configuration. right? That's where my electrons are at. That's their physical address. Now I need to do my orbital diagram. My orbital diagram is just taking this and drawing it in pictures, right? Like this guy up here. So once I have the electron configuration, doing the orbital diagram is really easy because all I've got to do is translate this. So 1s, s has one orbital, it holds 2 electrons, one up, one down, label it 1s. 2s, one orbital, one up, one down, label it 2s. 2p, now p has 3 orbitals, 1, 2, 3. All of them together are 2p, so I'm going to label that 6. So remember, Hunds rule, up, 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 down, down, down. Then I'm going to go to 3s, up, down. Then I'm going to go to 3p, 1, 2, 3, 3p. I have 5, up, 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 that's 3, down, down, that's 2 more, so it's a total of 5. So there's my orbital diagram. Okay. And then the last question about this chlorine that I want to answer is, well, how many unpaired electrons are there? Right? Who's hanging out without a buddy? Just this one. So how many unpaired electrons do I have? 1 unpaired electron. Easy peasy. All right, let's do another one. So the next one that we're going to do is vanadium. Vanadium has 23 electrons. Okay, so 23 electrons. So just like I did with chlorine, I'm just going to start at 1s, start filling them in till I run out. So I've got 23. So 1s holds how many? 2. 2s holds how many? 2. 2p holds how many? 6. So 2 plus 2 is 4 plus 6 is 10. So I've used 10 of my 23. I've got 13 to go. What comes after 2p? 3s holds 2. Then 3p holds 6. So now where am I at? 2, 4, 10, 12, 18. We've got 5 more. What comes after 3p? 4s, 2. So now how many do I have left? Should have 3 left. What comes after 4s? 3d. Now 3d can hold 10, but I don't have 10. I just have 3. 3d3, right? Check your math. 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 3 is 18, plus 2 is 20, plus 3 is 23. All right, so there's my electron configuration. Now let's look at our orbital diagram. Take this, turn it into a picture. 1s, 1 up, 1 down. 2s, 1 up, 1 down. 2p, up, 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 down, down, down. 3s, 1 up, 1 down. 3p, up, 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 down, down, down. 4s, 1 up, 1 down. 3d. Now, here's where you have to really pay attention. So the 3d has 5 orbitals. It does not matter that I did not use all 5. I still have to draw them. Okay. 1, 2, 3, 4, 5, 3d. Label them. I have 3 electrons. So you got to really make sure you're keeping track of your Hunds rule. Got to do the up, up, up before the down, down, down. Well, for a D sublevel, I've got to do 5 ups before I do any downs. I don't have 5. I only have 3. So I'm going to just 1, 2, 3, and that's it. That's all I can do. So in my orbital diagram for this, how many unpaired electrons do I have? Okay, think about it for a second. Are these 2 blocks unpaired electrons? Or are they just empty? They're just empty, right? So I have 1, 2, 3 electrons without buddies, And I got some empty spaces, right? I only concern myself with those 3. So 3 unpaired electrons. Okay. So what can I ask you about this? Well, there's a series of different questions I can ask you when you write out an electron configuration, or if you're given an electron configuration that asks you to analyze what you're seeing here. So we're going to go over 3 of those examples with this vanadium. So let's look at the first question. First question is, what is the highest energy level? Okay, so you need to think, in my electron configuration, which part of the 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10 represents energy level? Is it the little exponent numbers? Is it the letters? Or is it the big numbers? Okay, what is the energy level? Well, the energy level is the big numbers, right? So both of these 2 are in the same energy level. These 3 3s are in the same energy level. This 4 is in the same energy level. 4 is going to be my highest energy level. Think about these like concentric circles, right? 1, 2, 3, 4, and I could keep going 5, 6, 7. Even though I fill the 3D after the 4S is still outside of the 3D, right? The 4 is a higher energy level. So even though 4 is written first, it's a bigger number. It's further to the outside. It is a higher energy level. Okay. 2, where are the outermost electrons located? Where are they located? Well, shouldn't the outermost electrons be the ones in the highest energy level? And in this case, if the highest energy level is 4, wouldn't the outermost electrons be the 4s electrons? Would make sense. Okay. And then the last question, how many total electrons are in the second principal energy level? Well, is calling it a principal energy level make it any different from an energy level? No, right? It's just more words. So where's my second energy level? Well, everything that has a 2 in front of it, so 2s and 2p is my second energy level. How many total electrons do I have there? Well, 2s has 2, 2p has 6, 2 plus 6 is 8. Right? So those are examples of types of questions that you can be asked from an electron configuration. All right. The last thing that we're going to do with this introduction is to go over kind of one longer electron configuration. So the one that we're going to look at is erbium. And erbium has 68 electrons. Okay. So with a long one like this, it's really helpful to have your off-ball tree in front of you, to put your finger on it, to slide down those arrows so that you can track where you are, and so that you can keep track of the number of electrons and you don't go over or drop under how many you need. So with 68, I'm going to make it pretty far through that tree of electrons. Right? So we're going to just start going, and we'll kind of spot check as we go and see kind of where we end up. So erbium, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, right? So 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 6 is 18, plus 2 is 20. Well, I've got 48. I've used 20. I've got 68. I've used 20. I have 48 to go. So got to keep going. So what comes after 4s? All right, 3d, 10. So now I had 48 left. Now I have 38 left. So I got to keep going. After 3d, 4s, 4p6, 5s2, 4d, 10, 5p6, 6s2. So let's see where we're at now. So here we were at 20, so 30, 36, 38, 40, 50, 56. So if we're at 56, we have 12 more. What comes after 6s? 4f. And 4f can hold 14. We have 12. So 4f, 12. All right. And then now take that, turn that into an electron orbital diagram. So it's no different from the short ones. It just takes a little longer. 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, and then 4f. F has 7, and we've got 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 4f, and how many unpaired electrons? 2. All right. Tedious, yes. Hard, absolutely not. Okay. What do you have to watch for? Well, make sure when you are writing an electron configuration, you write it just like this, right? No commas, no dashes, nothing extra. We've got energy level, lowercase letter for the orbital, exponent for the number of electrons, right? Just like this, nice and clear in the order that off-ball dictates. For your orbital diagrams, make sure you can see the individual orbitals. So the dashed lines you're putting these on, make sure that you can see them. Make sure that they're labeled. If you want to do something like this, when you're labeling them to show which ones all belong, that's fine. You do you. But make sure they're labeled. No one wants to look at a mess of orbital diagrams that aren't labeled, right? I'm not going to go through and count all of those electrons if you haven't labeled them. So make sure that you are labeling your electrons. Make sure that it is legible, okay? Go forth, make electron configurations.